Welcome viewers, in this video we will see the solved problem based on the Thevenin's theorem containing the DC circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. The problem is determine the current in the network by using the Thevenin's theorem. The network is given. We need to find the current I. This is marked as terminal AB. It's called a load terminal AB. 100 ohm is connected between AB. So this is the load resistance RL. Right? This is load current IL. The load terminals are marked as AB. Here the two sources available. 10 voltage source in series with 4 ohm is connected. 12 voltage source in series with 6 ohm is connected. So the step 1 is we need to convert this complicated circuit into Thevenin equivalent circuit. What is Thevenin equivalent circuit? Thevenin equivalent circuit is nothing but the complicated circuit is converted into V Thevenin connected in series with the R Thevenin. Voltage source connected in series with the resistance. This V Thevenin is nothing but open circuit voltage. The terminal AB are open circuited, and we need to calculate that the voltage across AB, that is called V Thevenin. R Thevenin is nothing but the resistance across AB by removing all the sources. Both current and voltage sources are removed, and we need to calculate the resistance across AB, that is R Thevenin. So the complicated circuit is replaced with single voltage source and single resistance. So this is the terminal AB. Here we have load resistance RL equal to 10 ohm. This is load current. So now see this, the circuit is simplified. We can easily calculate the load current. IL equal to V by R. V is nothing but V Thevenin. R is nothing but R Thevenin plus RL. The two are connected in series. So we can easily calculate the current IL. So that is the aim of the Thevenin theorem. Complicated circuit is replaced with simple equivalent circuit, that is V Thevenin connected in series with the R Thevenin. So in the second step we need to find V Thevenin value. Third step we need to find R Thevenin value. Finally we need to find the IL value. Right? Now we'll go to find the V Thevenin voltage. So step 2 is to find V Thevenin. From the given circuit disconnect RL. We already know that V Thevenin is the open circuit voltage across AB. Load terminal is open circuited. The voltage across AB is nothing but V Thevenin. We need to find this V Thevenin by removing the voltage source. Now we already know that 10 voltage is available connected in series with the 4 ohm. 12 voltage is available, that is connected in series with the 6 ohm. So what is the voltage across AB is nothing but voltage across either this arm or this arm, that arm. Both are same, all are same. V Thevenin is equal to voltage across this arm or voltage across this arm. So that first we will find the current flowing through this circuit. The I equal to V by R. V is nothing but 12 voltage and 10 voltages are there. Both are opposing. So 12 minus 10. Both are not connected in series. Both are connected in opposite. So that 12 minus 10. The resistance is 4 plus 6. 10 voltage. So 12 minus 10, 2, 4 plus 6, 10. So it is 0.2 ampere. So the 0.2 ampere is flowing through in this circuit. So voltage across this arm is equal to V Thevenin. V Thevenin equal to VAB. Right? So that is nothing but what is the voltage across this? Is 6, the resistor available. So 6 into I minus 12. So this voltage is available, 12 voltage is available. Some of the voltage will be dropped across 6 ohm. The balance will be available across V Thevenin. Similarly, if you take this arm, 10 voltage is available. Some of the voltage drop across 4 ohm. Remaining will be available at the terminal AB. So that 6I minus 12. Right? 6 into I is 0.2. 6 into 0.2 minus 12. That is 0.12 minus 12. That is minus 10.8. So total 12 voltage is available here. In that 0.12 voltage is dropped across. The balance is available at the V Thevenin is minus 10.8. Similarly, we can calculate here also. Right? 4 into I minus 10. So that you will get same thing, 10.8. Right? So voltage across AB is Thevenin, that is nothing but voltage across either this arm or this arm, right? That is this arm, we have already 12 voltage sources available. The drop across this balance is available as the terminal voltage AB. So that is calculated here. 6 into 0.2 minus 12. So 0.12 minus 12, it is minus 10.8. So Thevenin value is calculated. Now we'll calculate the Thevenin. So Thevenin, how we are calculating? Remove the voltage source. Removing voltage source means short circuited. Here two voltage sources available, that are removed now. Only resistors are connected. Now we need to find what is the resistance across AB, that is Thevenin. So you have to see from this end, right? So you have to follow this end. So these 4 ohm and 6 ohm are connected in parallel. We can easily identify. At this point, the current is diverted. 4 ohm and 6 ohm are connected in parallel. So Thevenin equal to Rab. So the both are same. The parallel means R1 into R2 divided by R1 plus R2. 4 into 6 divided by 4 plus 6. 24 divided by 10, that is equal to 2.4 ohm. Right? So Thevenin is nothing but the resistance across AB by removing all the sources. Here two voltage sources are removed. After that the circuit is simplified. Easily we identify both are connected in parallel. So we apply the parallel formula. R1 into R2 divided by R1 plus R2. We calculated 2.4 ohm. Right? So Thevenin also calculated. Thevenin also calculated. Now we'll go to the Thevenin equivalent circuit. So the step 4 is to find the RL. This is the equivalent circuit. Thevenin connected in series with the Thevenin. Then load terminal A, the load resistance 10 ohm is connected. This is the load current IL. Thevenin we calculated minus 10.8 voltage. Thevenin we calculated 2.4 ohm. See this, now the circuit is simplified. We can easily calculate the IL value. IL equal to V by R. Thevenin divided by Thevenin plus RL. There are Thevenin available and RL also available. Both are added. Thevenin we calculated 10.8 divided by Thevenin is 2.4 plus the load resistance is 10. The negative sign is not a problem. We can get either positive or negative value. The value will be remain same. So 10.8 divided by 12.4, that is 0.871 ampere. Right? The load current flowing through this 10 ohm is 0.871 ampere. So in this problem we discuss find the load current using Thevenin theorem. The Thevenin theorem is the complicated circuit is converted into Thevenin in series with the Thevenin. Thevenin is open circuit voltage across AB. Thevenin is resistance across AB by removing all voltage source. After drawing this equivalent circuit, the circuit is very simplified. Easily we can calculate IL, that is nothing but V divided by RL plus RTH. So we calculated the value 0.871 ampere. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.